Hello guys, in this very lesson, we're going to be balancing some chemical equations. In our previous lesson, we discussed the history of chemical equations, and we also talked about the various classifications of those very equations. So today we're going to be looking at a couple of worked examples on how to balance non-redox chemical equations. So look at what we have right here on the board. Calcium plus oxygen, which gives us calcium oxide. So how do we balance this very stuff? Now, before we even talk about balancing this, now, first of all, there's something I would love us to quickly, understand. And there's it. First of all, we should be able to tell the amount of atoms each, element has in a given compound. So we look at calcium. How many atoms of calcium do we have here? We have just one atom of calcium, as you can see. How many atoms of oxygen do we have here? We have two atoms of oxygen. This is a molecule. And even when you look at the product, there's a reactant, there's a product. For the product, also one atom of calcium and one atom of oxygen. So calcium here one, oxygen here two, oxygen here one. So it means this reaction or this equation is not balanced. Oxygen is not balanced, calcium is balanced. And also before we derive this quickly, let's look at more complex chemical compounds. Let's imagine, let's say aluminium sulfate. Let's say this aluminium sulfate. So Al2SO4 in bracket 3, there's a smaller atom, out here. So how do we get to know the amount of atoms each of this element has? So we have aluminium here, we have sulfur, we have oxygen. So how many atoms of aluminium do we have here? As you can see, aluminium here is just two atoms. As you can see, the 2 is placed next to aluminium. Now, when you look at sulfur here, just sulfur right in this bracket or in this parenthesis, sulfur has one atom, oxygen has 4 atoms. So apart from that, we have a major, player out here. You can see there's 3 here, just placed very close, to this bracket. So you have SO4 with 1, 3 outside. So this very 3 affects everything in the box. So this 3 atoms affect the sulfur and the oxygen. This 3 does not have any business with the aluminium. It doesn't have any business, except the aluminium also is in the box. It's in the bracket, I mean. So how many atoms of aluminium do we have here? Aluminium, we have just 2 atoms. Sulfur, we have 1 atom of sulfur here. You're going to multiply that with the general 3 atoms out here. This substrate. So we have 1 times 3, which is 3. Then oxygen, we have 4 atoms of oxygen. We're going to multiply that with this 3. So this very stuff out here affects everything in the bracket. So this oxygen is 12. So let's also try this out. Let's see this. If you have 3, let's say 3 aluminum, let's try something like this. So let's say you have a 3, general 3 here, this coefficient attached to every one of them. As you can see, look at this very stuff. Al2SO4 in bracket 3. So we have a 3 here, being attached to everything. So we have like 3, like say 3 molecules of this. So Al2SO4 in bracket 3. So let's see, this very 3 affects everyone. Affects both this one outside the bracket and this set of atoms of element in the bracket. Don't forget the rules. This very smaller atom here, the substrate, affects only the ones in the bracket, as you can see. But this very general one out here affects both the one outside the bracket and the ones in the bracket. This has a telling impact on everybody, both the ones outside and the ones in the bracket. So how many atoms of aluminum do I have here? Aluminum naturally is 2. With this general 3 here, aluminum is 6. How many atoms of sulfur do I have here? Sulfur generally is 1. There's a smaller, atom placed out here, the substrate, this 3 placed here. That makes sulfur 1 times 3, 3 as you can see there. Together with this very general 3 here, that makes it 9. 3 times 3, 9 times the 1 it has here. That is 9. Then oxygen has 4 immediate atoms, as you can see. Now, together with this 3 here, the smaller one, the substrate, then alongside the general coefficient 3. So how many atoms of oxygen do we have? We have 3 times 3, 9. 9 times 4 is 36. So it's very important we get to know, it's very important we have the skills to know the amount of atoms each element has in a given compound before we can, go into this balancing of non-redox equations. So I think this is very clear. So calcium here plus oxygen give us calcium oxide. So first of all, for the reactant calcium, you have just 1 atom of calcium. Oxygen just 2 atoms of oxygen, I beg your pardon. Then for the product, we have 1 atom of calcium and 1 atom of oxygen. So the calcium balanced 1, 1. The oxygen 2 here, 1 here, oxygen is not balanced. So first of all, we're going to be using the trial error. the trial error method. That's the first. It's very common. This method can easily work on simple, questions, simple chemical equations, just like this very stuff you're solving. So you're going to try the various coefficients. You're going to attach it to, some of them to the reactant and some to the product to try to do that to balance out the whole thing. So I have my calcium here, I have my oxygen here, and I have my CaO here. So calcium settled. Let me just leave that out first. I'm going to focus first on the ones that are not balanced. Oxygen is 2 atoms. Oxygen is 1 atom. So what do I do to balance the oxygen on the product side? So if I add a general 2 here, a coefficient 2, that makes the oxygen here becomes 2. Don't forget, whatever is here affects everyone, both the ones in the parenthesis that's in the bracket and the ones outside the bracket. So this 2 affects calcium. That makes calcium 2 atoms now, and oxygen now 2. So oxygen is balanced. We have 2 atoms of oxygen, 2 atoms of oxygen, but calcium has been unbalanced. We have 2 atoms of calcium and 1 atom of calcium here. So how do we balance the calcium on the reactant side? Just going to simply add our word, our 2 to it, and that makes it balanced. So we have 2 atoms of calcium, 2 atoms of calcium, 2 atoms of oxygen, 2 atoms of oxygen, and that is how to balance this using the trial error method. As simple as that. So we could also use the other method, which is called the algebraic method, but probably we're going to use the algebraic method. Let's leave the algebraic method for complex worked examples. Okay, guys, here's another worked example. We have work example 2. We have hydrogen gas, a molecule, plus chlorine gas, another molecule, both combining together to give us hydrochloric acid, HCl. So is this very equation balanced? For us to get an this balance, we're going to check first the amount of atoms, of the reactant element, both on the reactant side and on the product side. So if you look at hydrogen here, we have 2 atoms of hydrogen compared with 1 atom of hydrogen here. Chlorine here is 2 atoms of chlorine. Chlorine here also is 1 atom of chlorine. So as you can see, this is not balanced. Hydrogen 2, hydrogen 1, chlorine 2, chlorine 1. So how do we balance it? Let's start with hydrogen first. So we have 2 atoms here, while here 1 atom. So how do we balance this? We add 2 to this. When we add 2 to this, hydrogen becomes 2. Hydrogen here is 2. Hydrogen is balanced already. So as you can see, if hydrogen is 2 here, then chlorine automatically 2 is 2. According to the rule here, this very coefficient affects everybody, both the ones outside the bracket and the ones in the bracket. So chlorine here is 2, chlorine here is 2, hydrogen 2, hydrogen 2. This very equation is balanced. Okay, guys, let's look at the third and final worked example in this very lesson. So we have aluminium plus HNO3. There's a hydrogen nitrate, this form of acid, both combining to give us aluminium nitrate plus H2. As you can see that. So now in this very question, we're going to be using the algebraic method. We can also use a trial and error method, but the trial and error method, you may end up struggling to use it effectively when it comes to some very complex, even things that are far more complex than this. So, but we're going to use the trial error method, and then we use the algebraic method. So first of all, how do we balance this? Let's see if some of the atoms of elements here are balanced. So we have aluminium here. How many atoms of aluminium do we have here? On the reactant, we have just 1 atom. Aluminium here is just 1 atom. Hydrogen here, we have 1 atom of hydrogen compared, to this 2 atoms of hydrogen that we have right here on the product side. Nitrogen is just 1 atom. Nitrogen here is 1 atom, but we have, a substrate. We have something here, smaller stuff here, that's going to affect everyone, just the ones in the bracket, not the ones outside. So nitrogen here is 3. Nitrogen here is 1. That's not balanced. So oxygen is 3 atoms. Oxygen here is 3. That's going to multiply with this. Oxygen here is 9. So oxygen is not balanced. Nitrogen is not balanced. Hydrogen is not balanced. Only aluminium is balanced. But if we use the trial and error, let's try to see if that will work out. So the first thing, aluminium is balanced, yes. Well, others are not balanced. So hydrogen here is 1. Hydrogen here is 2. So that means if you add 2 to this place, just try and error. If you add 2 to this place, that means hydrogen becomes 2. Hydrogen becomes 2, super balanced. So let's see, nitrogen is 2 here, but nitrogen here is, as you can see, nitrogen here is just 3. That's not balanced. So if nitrogen is no more balanced here, so what do? You have to balance it. Oxygen here is 6. Oxygen here is 9. So what do we do? How do we balance this? How do we balance the nitrogen? So for us to balance the nitrogen, It simply means that since nitrogen here is 2, nitrogen here is 3, so what it means is that even this nitrogen is not up to what is here. So that means I may have to remove this 2. I may have to remove this 2. If I remove this 2, if I say, okay, let me try 6, just trying 6. Let me try something bigger. If I say this is 6, that's hydrogen. Hydrogen is 2. If I add my 3 to this, that makes it 6. I can't put 5 here because if I put 5, what will I times to this to make hydrogen becomes 5? Like 2.5, no, that's not going to make sense. So let me say 6, and here is 3. So if hydrogen here is 6, hydrogen is balanced, then nitrogen is 6, nitrogen here is 3. So how do we do that? How do we balance the nitrogen? This is how we balance the nitrogen. If this is 6, why this is 3, so we can add 2 to this place. When we add 2 to this place, that means nitrogen becomes 2 times 3, 6, that's 6 nitrogen. So oxygen is 18. The oxygen is 2 times 3, 6 times 3, 18. Wow, that is balanced. Oxygen 2 is balanced. So aluminium here is now is 1. Aluminium here is 2. So I'm going to add 2 to this place to make the aluminium balance. So there's a trial and error method. The trial and error method is just keep trying different coefficients, attaching stuffs to see if it's going to be balanced or not. But this is not the best. For complex stuff, the best is the algebraic method. So I'm going to be using the algebraic method right now. So I'll be taking this off, and then we're using the algebraic method right away. So how do we use the algebraic method? There's an algebraic method. So for us to use this method, there's something you have to understand. You're going to you're going to attach coefficients or attach coefficients to the reactant and also to to the product. But this is it here. You're going to leave out one of the stuff right on the board. You're going to leave out either one of the reactant or one of the product. While others will take certain coefficients. That's what we're going to do. So others will take coefficients, but one of them, either product or reactant, is going to be left out. So let's see how that goes. So I mean, just attach A to this place. I can attach B to this place. I can choose to leave this one and then put C here. Or if I like, I can put C here and leave this one. I can even leave this. I can start A, B, C. So the fact is, you attach coefficient A, B, just attach coefficient, then choose which of them. Whichever one you leave, you're going to get the same result. You can choose to leave one of the product, or you decide to leave one of the reactants. So I've done this already. A, B, I leave this out, and I put my C here. So the next thing, you're going to write out a couple of simultaneous equations from this. Aluminium right here. How many atoms of aluminium do we have? We have only one atom of aluminium here. So if you have one atom of aluminium here, what are we going to do then? It means one atom times this coefficient. So 1 times A is A. So do you have another aluminium on the reactant side? No. Equals to, let's check the product. For the product, only one atom. There's no coefficient attached to it. So A is equals to 1. That is done. You're done with that. So next, you're done with aluminium. Next is hydrogen. For the hydrogen, how many atoms of hydrogen do you have here? 1. 1 times B is B. Another hydrogen, no more on the reactant side. So for the product side, hydrogen is 2. 2 times C is 2C. So we're done with hydrogen. The next is nitrogen. That's the next element. So nitrogen is just one atom. 1 times B is B. That's the nitrogen right now. So nitrogen here is, we have 1. 1 times 3 is 3. So that's just 3. There's no attachment, no coefficient here. 1 times 3 is 3. So we're done with the nitrogen. So the next, oxygen. So let's see, for the oxygen, how many atoms of oxygen do we have? You have 3 atoms of oxygen. So 3 times B is 3B equals to, so no more oxygen. Let's go to to the product side. So we have 3 times 3 and 9. 3B is equals to 9. So I think we're done with all the elements. You have aluminium, hydrogen, nitrogen, we have oxygen, and I think that's all we're done. So we have a couple of equations. We're going to solve them simultaneously. Equation 1, equation 2, equation 3, equation 4. Now, there's a reason. The reason why this very method is far better than the trial and error method is, yeah, there's no guesstimate. There's no need trying to guess, the coefficients you're going to attach to the reactants and products to balance out the equation. You just have to solve it using your mathematical skills, your arithmetic skills to get the coefficient. So you have A now right equal to 1. You have A equals to 1. There's the red. Then B is equals to 3, as you can see. 3B also is equal to 9. Divide both sides by 3. we have B equal to 3. So if B is 3, it means C is what? So if B is equal to 3, it means we have B equal to 2C, I mean. So B is 3, 3 equal to 2C. Divide both sides by 2, it means C is 3 over 2. Don't forget B is 3, so it's 3 equal to 2C divide. So we have everything set out. A is 1, B is 3, C is 3 over 2. So we're going to take each of those coefficients, then we're going to fix them into this very equation. AL plus H under 3 and now down to the other side. So we're doing that right away. So that is A. So the A we have here is 1. That is 1 times AL plus the B is 3. Don't forget, just have them just hanging out there. So 3 times A channel 3. This then equals to the AL and O3 with a smaller 3 out there. Then plus the C, which is 3 over 2 times H2. So look how everything is well set out. Aluminium, we have 1. The A is 1. The B is 3. Then the C is 3 over 2. So right away, we have this 1 over 1, 3 over 1, and 3 over 2. So what do we have? 1, 1, 2. The LCM of 1, 1, 2 is 2. So we're going to use the LCM of 1, 2 to multiply all through. So that way, times 2, times 2, times 2, that's 2 times, then times 2. So 2 takes out 2, and everything is settled. So what do we have? We end up with 2AL plus 6HNO3. That'll give us 2AL NO3 with the 3 outside plus 3H2. The equation is balanced. The non-redox equation is balanced. So there's an algebraic method for you. It's very simple. Fill up the whole place with imaginary coefficients. Decide to leave one of them. You can decide to leave one of the product or decide to leave one of the reactants. Once you do that, state out the number of number of atoms on both reactant and product side. That is number of atoms of each element. Once you're done, solve it. Just solve it up here, then you're good. As you can see, it's the same result we got here. 2 aluminium, 6 hydrogen, 6 hydrogen, 6 nitrogen, 6 nitrogen, 18 oxygen, 18 oxygen. As simple as that. Okay, guys, at this very point, it's high time we got ourselves tested on how much we've gotten from this very lesson. So right here, we have a couple of questions now take home for us. So we have to balance all this set of non-redox equations at home. So first, we have B2BRSS plus HNO3 equal to B open bracket NO3 close the bracket 3 here plus 8BR. That's the first. Now look at the second. Aluminium trioxosulfate plus sodium hydroxide plus Na2SO3 plus AlOH as aluminum hydroxide. So we also have the Cu plus HNO3 equal to CuNO32 plus NO plus H2O. And this very last one, Fe plus HC2H3O2, equals to Fe, all this in bracket 3 plus H2. So I'm very sure that we have what it takes to balance each of these non-redox and chemical, equations. So that's all for this very lesson. So if you have gained one or two things from this very lesson, I'll love you to subscribe to the very channel at EduMosaic, and also follow me at Revelation on Facebook, and also share this lesson with others. See you in the next lesson. Thanks and bye for now.